So we're going to keep going with the calculus and context stuff. We were in the middle of that amusement park problem with a rate that people were entering the park, a rate people were leaving the park. Can you go to page 5, reread the problem on page 5, and after you've done that, please store E and L in your calculator for L1 and L2. Page 5, problem 9. I think we did a lot of the parts of it but didn't finish it last time. Reread it, jog your memory, but then also store those two functions in your calculator. What was that?
So quiet.
Yes, it is quiet when we're missing people. We had a rate that people were entering the park, a rate people were leaving the park. Sai, if you want to get out your Chromebook, if you go to my website, there's a link to that calculator that I've shown on the screen before. Maybe you can try that. We got through part D, right? We created our function that predicted the number of people in the park at any given time. We plugged in 18 to find the people in the park at 6 p.m. And I think that's where we stopped. Okay. Are we kind of back and ready to go? In part E, I want to find h prime of 18 and explain its meaning. I know from part C that h of t is the integral from 9 to t of e of x minus L of x dx. I first need to calculate h prime of t, then calculate h prime of 18, and then figure out what exactly it's telling me. How would I find the derivative? How do I find the derivative of a function defined by an integral? What were you saying? Yeah, the second fundamental theorem of calculus, the derivative and integral cancel. The only difference is you're just going to plug in the t where the x was. Another reason why I was using the two different variables there. H prime of t is going to be e of t minus L of t. So, to find h prime of 18, you just need to do e of 18 minus L of 18. If those functions are stored in your calculator, use the variables y1 in parentheses 18 minus y2. As I think I made comments several times last time, make sure you're writing this using standard notation, though not calculator notation, not y1, y2. And I think it's actually a nice number.
Yeah.
Negative 689. Okay. I need to explain what this means. Any hands or people who may have an idea?
When it's, I don't know what time it is.
You could say t equals 18, or what is 8? 6 p.m.
The rate at which people are exiting the park is decreasing at a rate, or they're leaving at a rate of 6.
You're on the right track. Sai.
At 6 p.m., the rate of people in the park is decreasing at
You are close. I don't want to say the rate, and first of all, it would be the rate of change of people in the park, but I don't want to say that rate itself is decreasing. But I can't, what does H represent? Amount of people in the park. So the derivative of that would be the rate of change of the number of people in the park. That is one way I can say this. I can say this at t equals 18. The rate of change of the number of people in the park is negative 689. What kind of units? People per hour. H of t is giving you people. We're dividing by the units of t, so people per hour. So, this is one way to write it. There's a better way to write it. Say that again, Plady. What is decreasing? What is decreasing, though? Not the rate of change. The rate of change is not decreasing. That would be like my COVID example of the number of cases is increasing, but at a decreasing rate. That's not what this is talking about. The number of people in the park is decreasing. It would be wrong to say the rate of change of the people in the park is decreasing. We could say what I already wrote, or we could say at t equals 18. You could also certainly say 6 p.m. for all these things. The number of people in the park is decreasing at a rate of negative 689 people per hour? Good. Don't account for the negative both in your language and the number. If you're decreasing by a negative, that technically means you're increasing, which is not what's going on. 689 people per hour. Either tell me the rate of change of the number of people in the park is that negative 689 people per hour, or tell me, probably the better way to describe it, the number of people in the park is decreasing. Although, again, it would be wrong if you said the rate of change of the people in the park is decreasing, because that's kind of like you're looking at the derivative of h prime of t, h double prime, which is not what we're doing here. Do you see what's going on? And again, a lot of language stuff here. Part F. At what time does the model predict the number of people in the park is a maximum? I want to find a maximum of something. Do I want to find a relative maximum or an absolute maximum? How do you know that? Okay, the total maximum. They don't want a high number of people in the park. They want the highest number. There is something else, although that's not necessarily. Yeah, so you see that closed interval there? Now, absolute maximum, what does that mean I have to do? Oh, we've got this. Okay, so I need to find the absolute maximum of the number of people in the park. What is the number of people in the park? E of t, L of t, h of t, that function we created in part C. I want to find the absolute maximum of h of t. Remember in the beginning of the year, not the beginning of the year, November when we did those optimization problems, and I said, I don't really care so much about this stuff because this is not how you're going to be asked to find absolute maxes and mins on the AP exam. They're going to be more in another context. This is that context that I meant. You're not going to have to create a formula to find like the volume of the box when you fold it up. We're going to have to find maximums of these functions defined by integrals like this. First thing we need to do, I need my critical values. And my critical values occur where h prime of t equals 0, or where e of t minus L of t equals 0. And what's another way to say that? Aha. And what does that tell you you should be doing on your calculator to figure out critical values? Point of intersection of those two things. If you don't like that, you could also, I guess, do y1 minus y2 and y3. Turn off the other things, graph that, find the 0. I think point of intersection here, though, is going to be the way to go. Take a moment, go to your calculator. By the way, we're going to be using, we're finding a time right now. We're going to be using that in our calculations, which means I should probably give more than 3 places now, so my final thing will be as accurate as possible. Go get a time. Do you have your t? Okay, keep going. Find the t. Well, then I want to talk through that. I want to talk through that. Lotta, did you find the t? Go for it.
Like 46.
Oh, maybe not. I'm thinking 15 point. So, did you have the two things graphed and were you looking for the point of intersection?
Yes.
And were you giving the x coordinate of the point of intersection?
I found it.
15.79. No. Okay. Oh, wait a minute. I think you need to change your window so it's just between 9 and 23. And then maybe look higher. Make the y's go higher. And then I think you're going to find the 15. I think. Okay, next thing we need to do is we need to set up our candidates test. Normally the direction would say justify your answer. Justification is really just using appropriate candidates test work for something like this. I'm going to set up my candidates test. I'm going to say T for one column. What's the other column going to be called? H of T. What else do I need to include in there? The endpoints. Now, think logically. When will the most people be in the park? When it opens, when it closes, or that random time in the middle? However, you got to actually prove it, not just using like common sense. It had better end up being that time in the middle, but who really knows anything? You already know how many people are in the park though at time 9. Did?
Yeah.
Perfect. 0 people because they told you there were 0 people there. Now, how am I going to find the number of people in the park at time 15? Yeah, you're going to plug in that function you created in part C. So we're going to go and we're going to integrate from 9 to 15.794815. It is absolutely fine and probably the right thing to do to include the integral in your table. Unlike that one time I talked with you about cumulative reviews because you weren't given a function defined by an integral there. You were making your own integral. Here you have a function defined by an integral. We're good. Finally, 23, what are you going to do? I mean, I know what it should be, but how can you, what's your calculation going to be? Same deal. Go to your calculator, do your fn int stuff, and this is how we prove when we have the most number of people. That is fine, but you mean the work. That's fine if you do that somewhere else, as long as there's a calculation somewhere. They don't say anything about that, so just give the decimals, I guess. Although when we're done, we're not looking for the number of people, we're looking for a time, so maybe I was wrong when I said we needed to make sure that was accurate to many places. You getting about 3,950 or so? 3,950.680. How many people at time 23? Why is that person left in the park? There we go. That works. Okay. Some people get lost. I don't know. What's the answer? They wanted a time. When is that time? We're just going to give it as a t value. 15.794815 because I don't feel like rounding, but 3 places would be fine. Hours. What was that?
795.
70 what?
795.
Yeah, okay, fine. Michael.
I know why at 9 is 0.
do we just not have to show?
No, because they told you at time 9 there were 0 people in the work. Actually, if you did the work, it would be the integral from 9 to 9. That's 0. But more importantly, they told you in the problem, you're starting with no one in there. This will be different in the next one that we look at. Do you need to move, by the way?
Well,
Okay. Questions on this? And this is a pretty common question on the AP exam because this is how they're going to test. Can you do absolute maxes and mins, but not having to have you create a formula, but rather using a function defined by an integral or whatever. I would like you right now to read number 10 and maybe do the calculation in A, but we'll do the interpretation together. Read it, store the function in your calculator, and try to do the calculation for part A. Talia, do you have a number for that one?
This one?
Yep.
Negative 24.58.
Anyone having issues getting that? What is going on?
The rate of the rate is decreasing.
Okay, first of all, I'm not a big fan of the phrase the rate of the rate. Let's use like the rate of change of the rate that gravel is getting processed is this number over here. I don't want to say the rate of change of the rate that gravel's processing is decreasing. Hold on a moment to that. There are two ways we can talk about this. One way, first of all, what else do I have to refer to in an explanation? At t equals 5, I could say the rate of change of the rate gravel is being processed is negative 24.588. I'm going to give a better answer in a moment. What kind of units?
Tons per hour squared.
Tons per hour divided by your units of t, tons per hour or tons per hour squared. But there's a better way to talk about this that I feel like Plady was starting to get at, but something in her language made it a little bit wrong. She was talking about something decreasing. Sai, what's decreasing? Yes, not the rate of change of the rate that gravel is being processed is decreasing, but the rate that gravel is being processed, that G that you have, is decreasing. So, I think the better way to explain this is, at t equals 5, the rate that gravel is processed is decreasing at a rate of 24.588 tons per hour squared. Please, though, don't put those two ideas together. Don't tell me the rate of change of the rate that gravel's processing is decreasing. That would technically be like the second derivative of G, not what we're dealing with here. I think you could probably figure out B. Try to do part B. Just the function, the derivative, and integral. Integral, you got the rate that gravel is being processed. Well, no, hold on. I'm totally wrong here.
Yeah, you are.
And I was wrong in part A.
Yeah.
And no one said anything.
Sorry.
You're supposed to say something. What should I have said?
The gravel is arriving.
The rate of change of the rate gravel is arriving. Yeah, you should have said something. And now the people at home are going to be confused. The rate that gravel is arriving.
I've got some weird gaps going on.
What was that?
Really?
I don't know what to say about your writing. Hopefully you're integrating g of t dt from 0 to 8. Are decimals okay? It's tons of gravel. Of course they're okay. Alexa, do you have an answer for this one? Say one more thing. Tons. Tons is good enough. Tons of gravel. Either of those would work. Michael? Okay. Part C. Is the amount of unprocessed gravel at the plant increasing or decreasing at time 5 hours? Show the work that leads to this. Here's how I'm going to do this. I think I first want to create a function that will find the amount of gravel, only because I'm going to need that in part D as well, and it might make C easier to understand if we create a function here. How about we call it A of T? So the amount of unprocessed gravel present at any time will be A of T, which equals. Are you starting with any amount of? Oh, okay. So I should include that over here, 500 plus the integral 0 to t of g of x. I'm not ready for that. This is actually like the amusement park problem, where there was a rate that people were entering and a rate that people were leaving. There's a rate that gravel is arriving and a rate that is getting processed, so you no longer have that unprocessed gravel. What was that? Even though that's a constant, the 100 tons per hour, even though that's a constant, that's the rate that gravel is getting processed, I'm going to subtract that rate that gravel is getting processed, no longer having unprocessed gravel there at the plant. This is what your function that would predict the amount of gravel at the plant, at unprocessed gravel at the plant at any time would look like. Yes? That should be dx in this case, thank you. And I had dt in my notes and I crossed it out and wrote dx in there and I ignored that over here. That should be dx, it should agree with the variable inside the integral. Now, I want to know if this thing itself is increasing or decreasing. I need the derivative of the amount of unprocessed gravel there, and then I'll plug into that. Okay, let's do the derivative. Let's do a prime of t. What's the derivative of 500? Easy. 0. What's the derivative of your function defined by the integral? So what is it? Close, not g of x, but g of t minus 100. By the way, this calculation we just did says the rate of change of the amount of unprocessed gravel is the rate that gravel is arriving minus the rate that gravel is getting processed. So I feel like that should make a little bit of sense. Let's plug in. I want to find a prime of 5. That means doing g of 5 minus 100. Go do it, and then answer the question and give some justification. What number? What's our answer? Decreasing. I do need to give a reason. Because a prime of 5 is negative. There was no a in the problem, but that's fine because I defined what a of t is in terms of what's in the problem. You could also say because g of 5 minus 100 is negative. You could say because g of 5 is less than 100 or something like that. But I think the best way to kind of think about these is create your function defined by an integral, because we're going to need it for other things anyhow. Do you see how I did that part? This is also a pretty standard thing that can be asked. Part D. What is the maximum amount of unprocessed gravel at the plant during the hours of operation? Maximum. What do I want? Cantor stress. It's going to be an absolute maximum because it's over that interval for the day between time 0 and time 8. Okay, so I want to find the absolute max. Am I still on the screen? Okay, absolute max of A of t. I first need to find my critical values, which is where A prime of t equals 0, which is where g of t minus 100 equals 0, or where g of t equals 100. And what I might do is on the calculator, I assume you already have g of t in there. Why don't you also type in, like for y2, the constant 100, and then you can find the point of intersection. Here, when we're done, we are going to want the gravel, not a time, so we're definitely going to have to get more than 3 places for our time to make sure the gravel stuff when we plug in is good. See what you can do with this. I feel like in this case there's only one critical value. You could certainly have more than one though. Does 4.9 something sound about right? 4.9234803 or so. We're going to use Canada's test. Make sure you're labeling your columns, T and A of T, which again wasn't in the problem, but I can, since I've defined an A of T somewhere, I can now use it. What else do you want besides that time? Endpoints. I think you can probably go from there using that function we created in part C. And here, I don't think it's obvious that it has to occur at that critical value. You could have the most when it first opens. You could have the most at the end of the day. Either of those 3 options are logical places for this. How do you justify? The justification is really just showing your Canada's test stuff, but labeling the columns appropriately, and things like that. Maybe 635 rather, 0.376, and then 525, 0.551. We care about the time in the middle in this case, although again, it could have been reasonable to be at either of the endpoints. What's our answer? 635, sorry, 0.376 tons of gravel is the maximum amount they're going to have there during the day. questions on parts of this? Your homework, by the way, is going to be 4 free response questions like these, where you're going to use these ideas and all that kind of stuff. There's one final thing, though, that I have to show you. I need to show you how to do this sort of work, not from necessarily given functions, but rather when the information is presented in a table of values. I'd like you to read problem 11 and just read. What is W? What does W mean? The temperature of the water, not the rate of change, the actual temperature of the water. I want to find W prime of 12. How do we do derivatives from a table? Let's find the slope of a secant line around the point I actually want to deal with. So rather than dealing with it at 12, how about I do the secant line through 9 and 15? This is not the actual slope, but it is the best approximation I can do given the very little information you have. Honestly, in the real world, usually when you collect data, you're not going to get an easy, nice function, but you can get things like this that you can work from. This was a calculator question, so yes, you can use the calculator. I think the one in the homework isn't. The numbers are a little nicer there. Go do that calculation, and then we'll figure out what this is actually telling us. Maybe 1.06 repeating. What does this mean? Hands, if you can tell me what this means. 1, 2. Only 2 people know what's going on. 3. Ethan, go for it.
Every minute, the temperature is increasing by 1.01 Fahrenheit.
So it's the rate of change of the temperature when specifically, not at every minute, but at one particular. Okay, so at T equals 12, the temperature of the water is increasing at a rate of 1.016 repeating. And what are the units again? Yes. Degrees Fahrenheit per minute, because we're finding the derivative of W, which is just degrees Fahrenheit. So, yes, rounding to 7 would be fine, but degrees Fahrenheit per minute. That's the temperature is increasing at that particular rate. I guess you could also say the rate of change of the temperature of the water is 1.016 degrees Fahrenheit per minute. Anything there? B is a little different. We want to figure out that integral. Oh, okay. What do you mean when you said first fundamental theorem of calculus? Okay. Isn't this going to be W of t evaluated from 0 up to 20, or W of 20 minus W of 0? Figure those out from the table, and then we need to figure out what this means. Maybe 16? Hands if you can tell me what we found. Only 2 people are with me? Only 3 people are with me? New hand. Charlotte. Yeah, this is, so W prime of T is kind of like the rate of change of the temperature. You integrated that, you got the net change in the temperature. Yeah, the temperature of the water changed by 16 degrees. And if you think about our calculation here, this is the temperature at time 20, this temperature time, sure, that's the change in the temperature. I like that you said over that interval from 0 to 20. I'm going to say over T equals 0 to T equals 20, the temperature of the water either changes by 16 degrees or increases by 16 degrees Fahrenheit, something like that. This is not the rate of change of the temperature. This is the net change, the total change in the temperature. Thank you. Sorry. Keep telling me those things. Okay. One more very important part. The average temperature in the water is given by that integral over there. I want to figure it out using a left Riemann sum with 4 subintervals indicated by the data in the table to So this goes like back to when we did our area approximations, drawing out the rectangles and stuff. I don't think the average part should make this much harder. Once we're done, we'll just multiply our answer by 1 over 20. I do think it may be a little bit of help. It's been a while since we've done these. I'm going to draw a little picture just so I can sort of orient myself here. I know that at time 0, the water is 55. At time 4, the temperature is 57.1. I know that at time 9, the temperature of the water is 61.8. I know at time 15, the temperature of the water is 67.9. I know at time 20, the temperature of the water is 71.0. I've got some sort of continuous increasing function, something sort of like that. What am I doing? Left endpoint sum, midpoint sum, trapezoid sum, right endpoint sum? Left, which means for my first rectangle, for my first region, I'm going to draw in a rectangle whose height is the height of the function at the left endpoint. It's going to be f of 0. That's my first rectangle. If I'm integrating from 0 to 20, w of t dt, this is going to be about, what's the base of that first rectangle? 4. And the height is the height at the left endpoint. I'm going to call it w of 0, but you could go straight to 55. Next. The next one, base is, what is the base? 5. You're going to get the height at the left endpoint. So 5 times w of 57.1. No, that's not. W of 4, sorry. How about you keep going? Because I think when I talk, I say things I shouldn't be saying.
Would they be mad if you skipped DW?
Nope.
0 part?
Nope. That's fine. I feel like you're going to get an answer that doesn't actually mean anything right now. What happens if you integrate the temperature? You get like degrees Fahrenheit times hours. That means nothing. But when you do the average part, then it will give you something kind of meaningful here. Are you getting 1,215.8? What's the average temperature? Kind of units? Just degrees Fahrenheit. We're integrating degrees Fahrenheit, but then dividing by the time and all that stuff. Yeah, it's just going to be degrees Fahrenheit. Is this an overestimate or an underestimate? Why? Okay, so there are this goes, again, back to stuff we did earlier in the year. There are two things we have to talk about. First of all, this is an underestimate. Because why?
The left.
Okay, we're using a left endpoint sum and? Say that again? Yeah, and the function is increasing. Because w of t is increasing, and we used a left endpoint sum. Both of those things must be included in your explanation, and I feel like in that salmon-colored packet that I gave you, there's something at the end about like overestimates and underestimates, goes through this stuff as well as the tangent line, overestimate, underestimate things with concavity. How about while I pass out the homework, you read D, and you see if you can figure out D. Here, there, 1, 2, 3, 1, 2, 3. Yep. 1. Do you guys know the temperature at time 20? What is it? Okay, let's take that starting temperature. This is the rate of change of the temperature over here. How can you take that and do something with it? Not plug in 25, because that would give us the rate of change of the temperature. Not plug in 5, again, that would give us the rate of change of the temperature. We need to integrate that rate to get the net change in our temperature. If I integrate W prime from 20 to 25, and how would you do that? Yeah, you have the right idea. Use your calculator. Go do it. I think we still have a minute. What was that? 73.043. Say one more thing. Degrees Fahrenheit. Tonight's homework is 4 free response questions like these. Yeah, they're going to be a little trickier than last night's homework. Use these packets, though, as models. In addition, you're doing 20 through 23 on the 2012 exam.